This video covers how to use the BRX's Modbus I/O scanner. Two Modbus protocols are supported, Modbus RTU and Modbus TCP. However, the Modbus I/O scanner is a client-only function. Modbus RTU hardware can be RS-232, 422, or 485. This is supported via the built-in serial port, or the SeriIO modules, or the various serial POM modules. To use Modbus RTU as a regular client and not a scanner, you would normally enable the Modbus RTU client device, then configure the serial parameters for the port, and then program the Modbus read-write instructions in ladder logic, taking care to select the proper device in those instructions. Modbus TCP as a client is supported by the built-in Ethernet port, or the ECOM-EX POM. The ECOM-LT POM does not support the client function, so it cannot be used. To use Modbus TCP as a regular client and not a scanner, you would use the Modbus TCP client device that exists by default. And since this operates over Ethernet, then the TCP IP parameters must be set. Then, like RTU, program the Modbus read-write instructions, making sure to select the proper client device in those instructions. But what about using these protocols as a Modbus I/O scanner? Ultimately, the scanner is used to automatically handle multiple Modbus slaves, or servers, making them part of the PLC's I/O cycle, without the need for manually programming the Modbus read-write instructions. So, is this functionality how we think about it? Sort of, but to understand why it is not entirely accurate, we review RTU scanners versus TCP scanners. Modbus RTU scanners. If we use RS-232 and the built-in serial port, then you could only have one server because RS-232 does not support a physical network. It is strictly point-to-point. Our scanner could use the internal serial Modbus client device. To have multiple RS-232 servers would require multiple physical ports, each with their own scanner client pairs. This is possible with the BRX SeriIO module. It has 4 serial ports. Thus, in the configuration, you would have 4 scanner client pairs as shown here. This same configuration is also for RS-422 because, like RS-232, it also does not support a multiple drop network. It is the BRX SeriIO 4 module that supports RS-422. RS-485, however, does support multiple devices on the same physical network. The internal serial port could be configured to handle RS-485. The configuration would still have separate scanners, one for each server. However, all scanners would use a single client, the already existing internal serial Modbus client. But what about TCP scanners? For a Modbus TCP configuration, it seems like it would fit the scheme that we originally imagined, or perhaps similar to the RS-485 RTU scanner. But no, unlike RTU, TCP IP protocol is a connection-based protocol. Thus, if we tried to use the original scheme, the problem will become apparent. First, a TCP connection has to be established with server 1. Then it would do the Modbus part. But then it would have to disconnect from server 1 and make a TCP connection to server 2, followed by its Modbus comms. And to do server 3 would require the same kind of thing. This means that the communication would be 2/3 connect, disconnect, and 1/3 Modbus comms. Obviously, not the most effective way to do this, so what is? The correct way is to have separate scanner client pairs. One of these clients could be the internal Modbus TCP client that already existed by default, but more likely you would want to create a different one so that you could give it a name that makes more sense in your application. In summary, there are 3 ways to imagine the Modbus I/O scanner configuration. One for RS-232 and 422, one for RS-485, and one for TCP. You can have up to 32 scanner client pairs to handle a maximum of 32 servers, and the clients can be any combination of RTU or TCP devices. The scanners don't care which. When would you use a scanner versus just manually programming the read-write instructions? Let's take an example. Let's say we have 3 servers, which we need to read and write some holding registers. This requires at least 3 Modbus read-write pairs of instructions. You could tie these instructions to the power rail and ladder logic and do more PLC. We'll cycle through them as fast as it can. But what if the data you needed to read and write was in non-contiguous location? Let's say 4 non-contiguous ranges. That would require 3 more pairs of instructions per server. Now we are up to managing 24 instructions. But let's also say that many of these data ranges require some pre- or post-processing, like byte swapping and such. This would add publish and subscribe instructions. Now things are starting to get out of hand. In this example, a single scanner for each server could handle all the reads and writes of non-contiguous ranges and the pre- and post-processing of the data. If we did this, the ladder programming would then look like this. And that certainly looks appealing. So, how do we configure a scanner? Well, let's look at a simple example. Let's say we have a BRX M that has 3 servers. 2 servers will use TCP, and the third will use RTU over 485. We first decide what we need to read and write with each server. Let's say the servers have the following Modbus memory as shown. Whatever is read from the servers must be stored somewhere in the client's memory, and whatever is to be written must come from the client's memory. Let's say we read various inputs and store them as shown. Then we write our outputs as shown. This is the specific scheme, and we'll refer back to as we configure. Let's configure a scanner for server 1. We'll pull up the system configuration, and you click on Modbus IO Scanner, and then enable it by putting a check mark in the Enable box. Next, press the Add Blank Device button. This will allow us to edit the scanner and client pair. Let's give this one a name of Scan H2 EBC 100. The client has defaulted to the internal Modbus TCP client, which would work, but its name is not useful. So we'll press the Add button to create a client with a useful name like Client H2 EBC 100. Pressing the OK button assigns this device to the scanner. Next, we enter the IP address of the server 1, which is 10.0.0.132, and we'll leave everything else as their defaults. That's the basic setup. Now for the Modbus comms. In our scheme, we want to read 8 inputs and store those into some C bits. To do this, we press the Add COM button, then the down arrow on the function code combo box to select the read discrete inputs. The offset address of 1 is good, but we want to read 8 bits, so we change the count to 8. Notice the Modbus address changes to show the proper range. We have the data, now what do we do with it? Press the Add Field button. The field name is optional, but we need to change the local address to start with C512, right here. Now you can see everything is set up, but we also want to add a COM to write 8 Modbus calls from some specific C bits. To do this, we use the same general procedure just utilized, that is, adding a COM and a field for that operation as well. The only difference is in the Add field, you are choosing where the data is coming from in the PLC, which will be written out to the server. Now, regarding server number 2. This is the second TCP server, and like server 1, we want to read 8 Modbus inputs into some C bits. So, in the same general procedure already outlined, we would add another scanner with a meaningful device name of Scan BX EBC 100. Add a new Modbus TCP client with a meaningful name of Client BX EBC 100. Use a new IP address. Then add a COM to read 8 Modbus inputs and add a field to store them in the designated C bits. Done. Now we are finished with server number 2. Now server number 3 uses Modbus RTU, not TCP. So its configuration is a tad different, but only a tad. Pull up the system configuration. Select the Modbus RTU client for the port. Then for the port type, select RS485. We'll leave the 120 ohm resistor enabled. Press the Change Internal Serial Device Setting button to change the parameters for the serial port if need be. Press OK button. Now the serial port is set up. Let's review the scheme for server number 3. For server 3, we're reading 4 input registers into in-memory and writing 4 in-memory locations to 4 holding registers. In the system configuration, click on Modbus IO Scanner. It displays our 2 previous scanners, which use TCP. Click on Add Blank Device. We'll give it a meaningful name of Scan BRX M. Since server number 3 uses the built-in serial port, click on the combo box arrow and select the internal serial Modbus client. We'll take the defaults for the ID and read and write intervals. Then, the rest of the configuration is exactly the same. Notice this section right here. This is where some post-processing could be performed on the data before it is stuffed into N0 to N3. It is also possible before we do a write to do some pre-processing. Also, there is another section here where you can choose the single field conversion instead of raw copy. Selecting this will convert the data to a specific format, and you can set the number of implied decimal points with the remote scale factor. Now let's continue with the configuration. There, we've added the COM field pairs according to our scheme for server number 3. This completes the Modbus scanner configuration for our application. By simply putting the client in run mode, all the defined comms will take place automatically and no ladder logic programming is necessary. But there are a few more things that you should know about the scanner. When a scanner is created, it creates a device structure containing members that can be used to programmatically control and or monitor the scanner's activities. However, there is an extremely useful tool called the Modbus Scanner Monitor. You can access this monitor from the menu at Debug Modbus Scanner Monitor. It looks like this. This shows the status of all the scanner structure members in real time and also gives you the read-write access to them by double-clicking on their status. Plus, using the combo box pull-down arrow, you can choose which scanner device you want to display on a particular row. And with the little gear icons, you have access to the configuration of both scanners and their devices. There are plenty of other features in the Modbus IO scanner not covered in this video, and one is the use of the MSREGRD and MSREGWrite instructions. These use the Modbus IO scanner device to read and write incidental locations of a server that you didn't want to or need to include in the normal IO scanning of that server. Another feature is being able to create a Modbus scanner based on pre-made server profiles, or profiles that you create and use over and over. These will be covered in another video, or you can learn their operation from the Do More Designer's help file. This concludes the video on Do More Brick's Modbus IO scanner. Thanks for watching.